ISI PEA 2007. Let's discuss question number 16 to 20 today. Please make a note of it. An n-coordinated function f is called homothetic if it can be expressed as an increasing transformation of homogeneous function of degree 1. So if I just take any homogeneous function of degree 1, now what will be a homogeneous function of degree 1? So if I have, say, y is equal to x, then this is a homogeneous function of degree 1. If I just take lambda, if I have my function as x, and then I go ahead and I take lambda x, this is going to be lambda x. This will be lambda times the original function, and power of lambda is 1. So this is homogeneous of degree 1. Now, if I just do any transformation of this function, so this function is a homogeneous function, and I do any increasing transformation, which means I multiply it with 2, I raise it to some power, right? Which is a positive power, or I go ahead and I take log, right? Or I raise it to exponential. I take any increasing transformation of this function, then that will be called as a homothetic function. This is what this question is saying. So f is called as homothetic function if it can be expressed as increasing transformation of homogeneous function of degree 1. Okay, now let's go ahead and read it out. So it says, assume that f1 is given to you like this and f2 is given to you like this. Then whether they are homothetic or not, that is what you need to go ahead and tell. Look into the first function better. Let me say that this function summation I from 1 to, instead of n, I take this as 2, xi to the power r, right? So this can be written as x1 to the power r plus x2 to the power r. So I have this function, this is x1 to the power r plus x2 to the power r. Before I can tell whether this is homothetic or not, I need to first check whether this is homogeneous of degree 1 or not. Only then I can do its increasing transformation. So if I just go ahead and say I take lambda x, this is going to be lambda x1 to the power r plus lambda x2 to the power r. So this is going to be lambda to the power r, x1 to the power r plus x2 to the power r. So this is going to be lambda to the power r into the original function. Now just imagine, what if your original r is, say, half, right? What if your r is half, right? Or what if your r is negative, for that matter? Or what if your r is a decimal, right? Say it is root 2, right? So r can, it need not be the case, right, that r will always be 1. R can be anything, right? So if r is half, then this function that I'm talking about, this is homogeneous of degree half, right? This is homogeneous of degree half. So in that case, I cannot say that this is homogeneous of degree 1. And if it is not homogeneous, how will it be homothetic, right? Look into the second function. The second function looks very easy to solve. So if I just take I from 1 to 2, and I have a1 x1, I will get a1 x1 plus a2 x2 plus b. So clearly, if I now go ahead and I talk about this, so I can look into it and I can say that my root function can be a1 x1 plus a2 x2. I can say that, let's say that there is a function gx which is a1 x1 plus a2 x2. And if I just take g of lambda, it is going to be a1 lambda x1 plus a2 lambda x2. And I can take lambda common and I will get a1 x1 plus a2 x2. So this is going to give me lambda into my original function. And therefore, this is a homogeneous function. So if this is homogeneous, I can do an increasing transformation by adding something to it. As long as b is positive, I've done an increasing transformation. I'm increasing the value of the function, and therefore I can go ahead and I can say that this is going to be a homothetic function, right? Am I clear with it? So therefore I can go ahead, and anyways b is a constant. Even if it is negative, does not matter. It will be fine, right? So I can go ahead and say that this is an increasing transformation of the function, right? I have transformed it in a way, I have added something to it, but the original function in the background is homogeneous of degree 1, and I have done an increasing transformation of the function. So therefore, I can go ahead and say that f2 is going to be a homothetic function. So we can say that A is correct. F1 is not homothetic, but F2 is. Come to the next question. So here it goes ahead and it says that you have a function hx, which is 1 upon 1 minus x. So you need to find h of hx. So if I just do h of hx, right, this is going to be h of, instead of hx, I will plug this 1 upon 1 minus x. That means everywhere instead of x, I will write 1 upon 1 minus x, right? So this is going to be 1 upon 1 minus x minus 1 upon 1 minus x. This is going to be 1 upon minus x upon 1 minus x. This is going to be 1 minus x upon minus x. This is going to be x minus 1 by x, right? So I will go ahead and get x minus 1 by x. This is h of x, hx. Now I need to plug this inside the function. So my function is hx is given to us as 1 upon 1 minus x. And instead of x, I need to go ahead and plug this value, x minus 1 by x, right? So I will go ahead and plug this x minus 1 by x. This is going to be 1 upon x minus x plus 1 by x. This is going to be x, right? So the right answer to this question will be x. Okay, come to the next question. This is whether this function is continuous, not continuous, etc., etc. Now what you need to go ahead and you need to notice here is that this is the sum of two functions. And if one of them is discontinuous, then the entire function will be discontinuous, right? Now look into this function first. So look into mod x by x. So mod x by x will become x by x if x is greater than equal to 0. And it becomes x by minus x by x if x is less than 0. So x by x is 1 and minus x by x is minus 1. So this function, this is going to go ahead and become 1 for all positive values and minus 1 for all when x is less than 0, right? So which means at x equal to 0, there is a discontinuity. From left hand side and right hand side, you are not getting the same value. So if this is not continuous, right? If mod x by x is discontinuous, then we can go ahead and say that the entire function will be discontinuous. So we can go ahead and say that it is not continuous at x equal to 0. Okay, look into the next question. Now here you are given, you need to integrate this function 2 upon x minus 2 into x minus 1 into x. 2 upon x minus 2 into x minus 1 by x. So you can go ahead and you can do it in this way. There are three values coming here. I mean, it's a product of three things. So what I can go ahead and what I can do in this case is I need to rewrite the numerator somehow in this case. So I can go ahead and I can say that this is equal to a upon x minus 2, or you can start from x also. You can do it in decreasing or increasing order, does not matter. So a upon x plus b upon x minus 1 plus c upon x minus 2. And of course, this will be equal to a into x minus 1 into x minus 2 plus b into x minus 2 plus c into x minus 1 into x minus 2 upon x into x minus 1 into x minus 2, and this will be 2 upon x into x minus 1 into x minus 2. Of course, this will cancel out and you will be left up with just the numerator, right? And if you look into your numerator, you realize that this is nothing but 2 is equal to a, x minus 1 into x minus 2 plus b, x into x minus 2 plus c, x minus 1 into x minus 2. Now there are two ways to go about it. Either you can go ahead and you can just open everything up and you will get these square terms and a coefficient with that, and then you will get this x term and a coefficient with that, and you will get this constant term, and you will realize that, and a coefficient with that, and you will realize that that constant term has to be equated to 0 and other two coefficients to, that constant term has to be equated to 2 and other two coefficients to 0. That is one way. Am I clear? So what I am saying, you will go ahead and you will open this up. So this will become x square minus 2x minus x plus 2 plus b x square minus 2x plus c x square minus 2x minus x plus 2. You will bring all x square terms together. You will get something here. All x terms together, you will get something here, and all constant terms together. This has to be equated to 0. This has to be equated to 0, and this has to be equated to 2. Right? This is how you can go ahead and solve this. This is method number 1. And find A, B, and C. Once you find this A, B, and C, you will just plug it here. And then we can just find their integration individually. Right? The other method of going ahead and doing is that, this equation that we have found right here, just remove this. The other method of going ahead and doing this about is that this equation that we have found out here, it should be valid for all values of x, because there is no limit given to me that x lies between this to this, right? This is not a definite integral. We're not talking about some numbers here. So this must follow for all values of x, right? So what you can go ahead and do therefore is you can start by putting x as 1 or 0, up to you. You can go ahead and put x as 1 or 0. Oh, this will be x. Sorry, this will be x. So you can either go ahead and put x as 1 or x as 0. You have to start with one value. Why am I putting x as 1? Because when I will be putting x as 1, I will be getting this as, this will go away and this will also go away, right? And it has to hold for all values of x. So when that happens, so I will go ahead and get 2 is equal to a into 0 plus b x into x minus 2 plus c into 0. X is 1. So here also I will put x as 1. So 2 is equal to b, 1 minus 2. So 2 is equal to b into minus 1. So b will be minus 2. So I will go ahead and I will find out that the value of b that I have here is minus 2. Right? Now I will redo the process. So now I will start by taking x as 0. Why 0? Because when I will be taking x as 0, again 2 values will be eliminated. So if I put x as 0, this will be gone and this will also be gone. So I will be left up with 2 is equal to a, 0 minus 1 into 0 minus 2. So 2 is equal to a into 2. So a will be 1. So I will get a as 1. So now I know that a is 1. Right? Now what I can go ahead and I can do is I can take x as 2. So if I take x as 2, I will get 2 is equal to a, 2, this will be gone into 0, plus this will be gone into 0, plus c, 2 minus 1 into 2. So I will get c as 1. So I've got this also. Now this is just simple integration. Nothing is left in this case. So now what you would have got is something like this. And if I were to integrate this, this is just logs, right? So I will get ln x minus 2 ln x minus 1 plus ln x minus 2 plus c. And if required, you can also simplify this together. So, because this is minus 2, this can go here in the power. So this will give me x plus log x minus 1 to the power minus 2 plus log x minus 2 plus c. And log m plus n plus g, this gives you log x into x minus 1 to the power minus 2 into x minus 2 plus c. And then x minus 2 can come in the denominator. It can come in the denominator. So log x into x minus 2 upon x minus 1 square plus c. And this will be the answer to this question. This would be the answer to this question. Am I clear with it? Okay. Come to the next question. It says experience shows that 20% of the people reserving table at a certain restaurant never show up. Okay. And it has 50 tables and takes 52 reservations. Then probability it will be accommodate everyone will be. So 20% never show up, which means 80% show up. So let's say that I am taking SU means show up. So probability people show up is 4 by 5 and probability people don't show up is 1 by 5, right? And now the probability I will be able to accommodate everyone, right? It will be 1 minus the probability I will not be able to accommodate everyone. And I will not be able to accommodate everyone only in two scenarios, which are that when I take 50, when I have 50 tables, what just happened? Not sure. Some balloons came up. I'm not sure if it was visible on the screen. Okay, I think I pressed something out. Anyhow. So when you go ahead and when will you not be able to accommodate? So you have 50 tables and 51 people show up. You have 50 tables and 52 people show up. That is when you will not be able to accommodate. So these are the two cases I won't be able to accommodate. So I have 50, right? And 51 people show up. And so 52 reservations. 52 reservations. I have 50 tables. 51 people show up, which means I will not be able to accommodate. So other thing is I have 50 tables and 52 people show up, I will not be able to accommodate. So out of 52 reservations, 51 reservations come, right? And so success is showing up. So out of 52, 51 people are showing up into probability of success to the power 51 into probability of failure to the power 1 plus I have 52 people and all 52 show up into 4 by 5 to the power 52 and 1 by 5 to the power 0. So you can just solve this now. 52C51 is simply 52 and this is 4 to the power 51 and 5 to the power 52 minus 52C52 is 1 and 4 to the power 52 and divided by 5 to the power 52. Right. Now this is just one small thing left here. So this is 4 to the power 51. If I need to make this to 4 to the power 52, then you can simply see that 52 can be written as 4 into 13, right? So I have taken this as 4 into 13. So this becomes 4 to the power 52 by 5 to the power 52 into 13 minus 4 to the power 52. So this becomes 1 minus 14 into 4 to the power 52. And that would be the answer to this question, right? Okay. Thank you, beta.